Master web development with Skill Bakery. Hey everyone, ready to level up your web dev skills? Introducing skillbakery.com premium courses starting at just $6 or 500 rupees. Sign up today and learn in-demand skill sets. Unlock your potential today at skillbakery.com.
Hello and welcome to another exciting video. Now in this one, we'll be learning how we can access WebAssembly.Memory directly from JavaScript. But before doing that, I would just like to recap on a few things that we covered in our previous lecture. So in our previous lecture, we created a Rust Webpack project using the Rust Webpack template. And while doing so, we also covered one more important aspect, and that's debugging a WebAssembly module written in Rust using console.log. So here, I would just like to highlight that part first. Like over here, we are making use of the console error panic hook. And this kind of provides better error message in debug mode. And the same we are then using over here, if you see console log, and the values are then being presented over here as hello world. And that's what gets displayed in our developer console. So now that's done, let's start with accessing WebAssembly memory directly from JavaScript. So if you notice over here, we have this Rust Webpack project, and within that, if you closely observe the webpack config.js file, it says that the index file resides inside the JS directory. Now let's go inside the JS directory, and over here we have the index.js file, which is saying that you will find the index.js file inside the package directory. So if I open up the package directory and open up the index.js file, now this is the file that gets generated. What we have done is, in order to demonstrate this accessing WebAssembly memory, we have updated this file. So whenever you will build it once and you will make any changes in your lib.rs file, this file will be rewritten. So the changes will be lost. But if you will just update this file only, then whatever changes you are making, that will remain in this particular file. So that being said, what we are doing over here, if you notice, these two lines are presented by default. So it says that import everything as Wasm from this index.vg.wasm file. Now this particular file is also within the package directory, as you can see over here. And it's also getting this wg set wasm from index.vg.js file, which is also inside the package directory. And then it's setting it over here, extracting the exports from the WebAssembly instance. And then it's making use of export statement and getting everything from the index.vg.js file. So here you can see all these methods that we generated, and the same are now being made available over here. Finally, we are making use of this statement wasm.wbyteGen start. Now what this means, if you go to lib.rs file, and here you notice this wasm byteGen and then start. That is what is being used over here to call. So by default, we have encoded everything as wasm. So we are saying wasm dot, and then when you do this dot, you notice the IntelliSense coming up. And from here, we are selecting this wbyteGen start, which internally calls the librs byteGen method main.js. Now once that's done, we are doing some extra stuff over here. So what exactly we are trying to do? If you notice, we are making use of this Wasm memory buffer. So what it means is, if I just log over here, console.log, after this method has been called, so here let's go ahead and say console.log Wasm memory, and this is going to output something. Let's see that. So here you can see it says memory and then 17. If you expand it, you will get the array buffer over here. Further down the line, you will get all these prototypes, integer 8, int, int 16, int 16, int 32 arrays. So this is basically the memory that the WebAssembly is having, and that's what we are accessing over here. Now, in order to demonstrate how we can access this, what we have done is, in our lib.rs file, we have created this struct called image. Now this image, if you see, we have the constructor where we are having two color attributes, color 1 and color 2, and they have their own values over here. Then we are creating a pixel out of this particular color. Now the pixel, if you see over here, is a vector of color. And color, as you can see, we have RGB values of type U8. So when we are creating this pixel over here as vector, we are passing these two colors, color 1 and color 2, and the image is then formed using the pixel. Now we have the pixel pointer, which is returning the color. So in WebAssembly, we often use pointers to interact with raw memory, which JavaScript can access through WebAssembly's memory object. And that's what we are exploring over here. So this function is important because it lets JavaScript access the image's pixel data stored in memory. Now, we have our image created over here. We have pixel defined, the colors defined. So the next thing is importing everything in our index file. So here, we've already done that using Wasm. What we are doing next is, if you notice over here, we are creating a new image instance using the WebAssembly. So we are saying Wasm.ImageNew, and this is going to give me the image. Once we have the image, we are passing that image to our image pixel pointer, which is again the method in our librs file. So here, this is the pixel pointer that gets generated, pixel as PTR, and this also can be accessed by having the intelligence over here. You can see image pixel pointer is coming up. Now, once we have the image over here and the pixel pointer is created, and over here, you can see when we are accessing the pixels using the uint array, down below, you'll notice the uint8 array. So these arrays that we had, see the values for RGB are coming up over here. So this is for color 1 and then this is for color 2. Now let's go back to our code. Now once we have that pixel data with us that we created over here as color 1 and color 2, what we are going to do now is we're going to draw those pixels as images. So for that, we have these methods over here. What we are doing is, first of all, let's go ahead and see. We're creating a canvas element. In that canvas element, we are appending that canvas element to our body. And over here, we're making use of the draw pixel, which is basically this method that you see over here, has the X and Y axis and then the color. So it's generating a 2D context. And in that, it's passing the color values. So R, G, and B. 3 colors are being passed over here. Each color is first changed or converted to a hexadecimal value, and then it's filling that shape using the fillRect method. And here we are passing X and Y coordinates. So exactly where it is going to draw that on the canvas, that is what we are passing over here. So for first, we have 0, 0, and the next one starts from as soon as the first one gets completed. So from that point onwards. Now, here you see pixels.slice. What exactly this is doing? Pixels, as I mentioned, is showing these 3 and then 3. So first 3 is for color 1, then the next 3 is for another color. So what we're doing is we're passing the first color combination, that's RGB value, to draw pixel. And here also, we are passing the next 3 color RGB values to this draw pixel method. Internally, we are collecting that as array, and you can see we are passing the index position to access those individual color items. And finally, the rectangle is drawn and shown to the user. So what we have demonstrated over here is that whatever values you're creating over here, and that's present in the memory, can be accessed directly in JavaScript, and it can be used to do certain functions. Like over here, we just created an image. So here, this is the image that we get using the memory data from WebAssembly. If you find the video helpful, don't forget to like and subscribe.